Okay, so hello everyone, welcome to Scienceholic's 2023 webinar, a journey into the world of chemistry. Thank you so much for your interested. Thank you so much for being interested in today's session about forensics chemistry. And we're so excited to welcome Dr. Manicke today to talk about his experience in forensic chemistry. I'm Jenny Dunn and I'm the host today for the webinar. And Jessica will be the co-host. She'll be helping out in the chat. And before we start, I just wanted to give a brief introduction about who we are. We are a youth-run nonprofit that aims to introduce intricate scientific concepts in a manner that is fun and comprehensible to teenagers. And we also provide volunteer and leadership opportunities to teens all over the world, including those who have English as their second language. And our main mission is to serve as a free resource for students to learn more about the various STEM topics. So other than this webinar branch, we also publish seasonal magazines. And our most recent one is published in April, and it's a biology themed magazine, which is our 7th edition. You can check it on our website later after this webinar. And without further ado, please welcome Dr. Manicke again, and would you mind introducing yourself to us?
Yeah, sure, it'd be my pleasure. My name's Nick Manicke. I'm a professor at Indiana University in Indianapolis, and I teach forensic chemistry there. Let me, if I can get my, yeah, there we go. So I teach forensic chemistry there. And the way that I came to be in my current position, I majored in biochemistry and graduated from a small university in Indiana. And I was interested in chemistry. I was especially interested in chemical measurements. So I ended up going to Purdue University in Indiana to get a PhD in chemistry with a focus on chemical measurements. And by chemical measurements, I mean identification of chemicals, measuring their concentration, determining what is in a sample. And as part of that research, I got involved in some forensic science applications of those technologies. And that's how I ended up getting into the forensic science field. I took my position at Indiana University in 2013, and I now teach forensic chemistry classes.
Nice, I see. Yeah, so thank you so much for that introduction. And we can start the questions. And if anyone that's attending right now has any questions, please put them in the chat and we'll go over them after the webinar. So the first question is, what sparked your interest in chemistry and forensic science? And how did you decide to pursue a career in academia?
Yeah, sure. And so I guess maybe before I answer that, maybe I'll just say like 3 minutes on what like forensic science and forensic chemistry are. Forensic science generally is the use of science to answer questions related to legal issues. There are many different subdisciplines of forensic science. They can range from highly specialized, like forensic odontology, which would be the study of like dental related stuff, teeth marks from bites, that sort of thing, to much bigger and more broad. The two broadest areas of forensic science are forensic biology and forensic chemistry. Forensic biology deals primarily with DNA related evidence. Forensic chemistry deals with the entire swath of chemical evidence. Now, there's a lot of different areas in which chemical evidence is important. For example, if you imagine a scenario where a pedestrian is hit by a car, the person driving the car drives away, and then later on the police locate a vehicle matching the description that has some damage to the front bumper. Okay, so how can we associate that damaged car with the person who got injured? Well, there's a lot of chemical evidence that's linking them. For example, paint from the bumper could have been, the bumper was damaged, so paint from the bumper may have ended up on the victim. Some fibers from the clothing that the victim was wearing might have ended up stuck to the damaged bumper. So now we have chemical evidence going both ways, connecting the car to the person and the person to the car. So the chemical analysis of those fibers or of those paint chips, that's an example of forensic chemistry and an important area. The single biggest class of chemical evidence is drugs. It is of all the different types of evidence that are submitted to forensic science labs in the United States, drugs are the most common. DNA is number 2, but just regular drug identifications are number 1. So that's a really big area of forensic chemistry, because all of those plants, powders, pills, those have to be identified by a forensic chemist. In other words, if there's a powder that someone suspects is cocaine, for example, that powder has to be identified through a series of tests to establish if it's actually cocaine or not. Okay, so that just gives you like the really quick, in case you're coming in with not much idea about what forensic chemistry is about, that's the 2-minute explanation. So my interest in chemistry started when I was in high school. I took an advanced chemistry class when I was 17 years old, and that was my favorite class that I took in high school. And so, not really having any better ideas, I decided to major in chemistry in college, and I very much enjoyed it. And during the course of my college, I got to participate in some research projects as an undergraduate student, and I very much enjoyed working in the lab. I liked the process of doing research, of working with my hands in a laboratory and trying to learn new things. So I decided I wanted to pursue research as a career, and that led me to entering a PhD program in chemistry. Now, while I was there, my research centered around developing some new methods of chemical measurement, and we applied those to a couple different forensic problems. One of them is this interesting idea of creating chemical images of latent fingerprints. So a latent fingerprint is like, if you have a surface and you touch it, it leaves a print there. And the physical shape of that print, as I'm sure you all know, is used a lot in forensic investigations to associate a person with a crime scene or a person with an object like a gun. Well, when a person leaves a fingerprint behind, they're obviously leaving chemicals behind on the surface. I mean, we can see the oily secretions from the skin. That's how we can visualize the fingerprint, but there's also chemicals in there. If a person had handled an explosive device, for example, they may leave residues of explosives behind in their fingerprint. That's the research. One of the research projects I worked on was looking for these interesting, forensically relevant types of chemicals in latent fingerprints. So really, I got through my chemical research, I worked on forensic science problems, and then therefore got very interested in it. And that's what led me to ultimately be a forensic science researcher. And then in terms of going to academia, rather than going into a forensic lab, for example, or getting a job in industry, jobs in industry tend to pay better. But working at a university has some nice advantages in that I can kind of do what I want. I mean, I have quite a lot of freedom in what I work on and how much, and when I come into work, that sort of thing. I teach classes. I probably spend about 1/3 of my time teaching classes. Most of my time is spent on research.
Nice.
Okay.
Have you like watched any like crime shows during, your high school years that kind of also pushed you into that route? Or
No, I came at it a little bit differently, I think, than a lot of the students that I've talked to. Many of the undergraduate students that come through Indiana University, I think a lot of them got initially interested in forensic science through watching like some TV shows, popular TV shows like CSI. But I really wasn't. I mean, I wasn't much interested in crime. Still not actually. A lot of my students, they're pretty interested in crime. They're interested in true crime stories. They are kind of fascinated by like serial killers and these other sorts of really macabre things. Me, I like crime and criminals has never really appealed to me much. It was really, I really came at it more from being first interested in chemistry and science, and then later becoming interested in the particular sorts of problems that you run into in forensic science.
I see. Okay, well, we can go on to the next question. Are there any memorable or fascinating experiences from your own career as a forensic science or researcher?
There's there's two things, several things that stand out. First, I don't have, sadly, I don't have like really cool stories. Like I said, I don't work in a crime lab. I'm not like investigating crimes or anything. I'm a professor. I teach classes. I do research. I've consulted on some cases as an expert witness, but there's not much to tell there. The For me, the most a really memorable experience in my career that stands out is when I first started supervising people to work for me and to help me with my research projects. Coming through school, of course, I was always the one being supervised. I was always had someone, a professor or someone directing me in my research. And then when I started at Indiana University and I had my first research students, that was cool. It was a little scary at first because I was just worried that I would waste their time or I wouldn't have good ideas for them to work on. And it seemed strange to me at the time that people would be like asking me what they should be doing and I would be giving them instructions. So, but it was pretty crazy when I walked into my lab and I had I had two students working for me my first summer there. And that was quite a step for me. Now, of course, I've supervised many students and become pretty used to it, I suppose.
That's nice. I done like a research program this summer as well. Um, and I think that it's a really great experience, like as a student, just to have someone there to guide you along the way. Um, and yeah.
Yeah, well, yeah, I think that's pretty essential. It's, starting out in research is a bit scary, and but the normal progression is someone starts in a lab and they have someone there to guide them, to teach them not only the technical things to do, but also like what should you be working on? Where do you even begin? Well, that's where your research mentors come in, and then the skills and also the knowledge, that comes later, and then people can start to work independently later in their training.
Yeah. Okay. It's kind of similar to the other question, but are there any books, documentaries, or podcasts related to forensic science or chemistry that you recommend for further exploration?
There are there are two documentaries that came to my mind. They're both they're both honestly kind of make forensic science look bad because they're both highlighting problems. But it's good to understand these problems so that one can understand how to improve the field. The first one is on Netflix. and it's called How to Fix a Drug Scandal. This is something that happened in the Massachusetts State Police Lab. There were two different forensic chemists who, well, broke the law. I mean, one of them, they were first of all independent and unrelated, but they happened coincidentally to be in the same crime lab. One of them was just fabricating results. Just dry labbing is the, I guess, polite way of saying it, but the chemist was simply inventing results. Rather than analyzing the samples and doing the analyses, the chemist was just making things up. And so as a result, innocent people went to jail, guilty people went free. There were thousands and thousands of cases affected. The other person seemed to be doing solid work, but was on drugs. This person was stealing drugs from the evidence locker and taking them. Now, these cases I've talked about in my class for years. These happened, I think, in, I want to say 2012 or 2010. I taught them in my class as sort of a cautionary tale to students. And so now with the Netflix documentary, it's really cool to be able to point students towards that, and it's pretty interesting. The other one is a documentary. You can find it on YouTube. It's called Real CSI, and it's produced by Frontline, which is a public broadcasting PBS thing. And it talks about there are some areas of forensic science which are actually not well established in fact or evidence. Some of them are pretty surprising, actually. There are certain areas that involve a lot of sort of expert opinions that are not necessarily supported in hard evidence. And this documentary delves into those things. And it's important to talk about those areas because ultimately that's a place where scientists need to do more work. They need to examine these problems more carefully and do the research to answer the questions that are needed.
Is there any resources online that you think might be helpful for just high school students right now who's interested in forensic science?
Gosh, there are, unfortunately, I don't offhand know. Sorry, I sort of am focused more on the college student level, but there are absolutely forensic chemistry textbooks, including one by a woman named Susan Bell. And it's appropriate for someone who's had a high school chemistry class. So I think if someone's had a high school chemistry class, there are a number of good textbooks that are sort of pitched at that kind of freshman high school or freshman in college kind of level.
Mm-hmm. I just think that the resources available for high school students aren't enough. I know that from where I am in New York, we don't have my school doesn't offer forensic science, and I don't know about other states, but I just think that do you think that there should be more classes available for students?
Well, I think it's not a bad idea because I think it's good to get people interested in science in general. And I think the particulars of what students are taught is not as important as teaching them about the process and the sort of ecosystem of science. And by what I mean is, we don't know something, we can make hypotheses, and then we can do experiments and collect data to determine if that hypothesis is correct or not. You can come at that from any number of different angles: biology, physics, forensic science. The good thing about forensic science is it's interesting. A big problem with high school science classes my humble opinion, is that they're extremely dull. Physics and chemistry are very, very interesting fields, really cool stuff to learn about and to do, but you end up learning about these topics which are pretty dull. I mean, I guess they are foundational topics. You get into chemistry and you learn about atomic orbitals and stuff, and it's important, but maybe it's a bit of a dry topic to start out on. Might be better to start off, teach people about science on actual interesting things that they want to learn about. So yeah, I agree. I think it's not a bad idea at all.
I see. Okay, so next one, what do you find most rewarding about teaching and mentoring students?
Well, the best thing about being a college professor is interacting with young people. It's because just young people have so much energy. They've got they're idealistic. They've got tend to have positive outlooks. They believe the world can change for the better, and so it's very refreshing and energizing in general to just be around young people. And so I've been on a college campus, I mean, for a long time, right? Because I started college in the year 2000. I got an undergraduate degree, I got a PhD, and then I started working at a university. So I've been on a college campus for 23 years now, and it's nice. I like it.
Throughout like your years of teaching, have you seen any like differences between the incoming students, like with their interest and like their motivation to learning this field?
I think forensic science has been growing in popularity, and I think that's because people can see what they can do in it. If you're thinking about science, you're thinking about, well, maybe I could get a degree in physics or psychology or chemistry, and it's maybe not clear what one would do with that. Forensic science, it's immediately obvious. People know just from their own experience and watching television or just understanding the legal system what a forensic scientist in general is going to do, and they see the societal benefit to it. So in general, we've seen in our program, a growing, just growing number of students. So it seems to be increasing.
Okay, thank you for that. And what advice would you give to students who aspire to follow a similar career path? Oops, sorry.
Well, so let's see. So speaking with a high school student, so if you want to be a forensic scientist, so you need to take science classes in high school. So high school students are generally, I guess, going to take physics, biology, and chemistry. Maybe high school students take computer science now. That wasn't really a thing when I was a high school student, but that may be more common now. And then student can go to a university that offers forensic science as a major. That's not essential, though. If there's not a university near you that offers forensic science, then a student could be a chemistry major or a biology major or a psychology major, depending on what sort of field of forensics they wanted to go into. But you absolutely can get a job as a forensic biologist, for example, with a biology degree, as opposed to a forensic science degree, because ultimately you've got the foundational training to do that. And then you want to, not get in trouble with the law, or so just avoid any kind of legal problems too, including legal drugs, just because at some point, if you want to work in a forensic science lab, they will give you a polygraph test and they'll ask you about illegal drug use. So, if you took cannabis 5 years ago, that's not a big deal, but just stay away from that during college.
Thank you. Okay, so next up is more about research. So can you talk about your current research projects and just like what you're involved in right now?
My research lab, we work a lot on toxicology. Toxicology is a study of poison. And the thing that poisons more people than anything else is drugs. There's a lot of people, people who use drugs have substance abuse disorders. Many of these drugs are extremely dangerous, and overdoses happen, people die. So a lot, practically speaking, a lot of what happens in toxicology is someone has died, and it needs to be established by a medical examiner how they died. And for someone, if it's a suspected drug overdose, then they need to send that off to get analyzed by a toxicology lab. And that toxicology lab uses various methods to identify what drugs are present in that person, in the deceased person's blood, and how much is there. And then a toxicologist makes the determination if that could have caused the person's death or not. Okay, so where do I come in? There is an entire large class of drugs called new psychoactive substances, also called designer drugs, which are structures often unknown to science. They are molecules that have not been abused historically. So by drugs that have been abused historically, I'm referring to drugs like cocaine or methamphetamine or heroin that have been known for a long time, and people have used them as drugs for a long time. Well, there are other drugs which just pop up on the black market. They're new. They're literally distinct chemical structures which may be unknown. And the reason these happen is in large part to circumvent drug control laws. There are a lot of laws that prohibit manufacture of drugs, and they also put strict controls over the materials that you need to make those drugs. And so, enterprising clandestine labs turn to these other molecules to circumvent those restrictions. Well, that makes it very difficult for the toxicologists to identify them because they're different molecules. The methods that toxicologists use to identify drugs are very much targeted to the particular known set of compounds. And so when you introduce new compounds, new drugs that are unknown, the toxicologist cannot detect them. And so you might have a spate of things that look like overdoses, but there's nothing there. Well, that doesn't make sense. And so what I do is I develop methods to improve the detection of these dark drugs that people don't know to look for yet.
And how many students work with you on this?
I have 4 PhD students and 1 forensic science master's student. And I have 3 or 4 undergraduate forensic science majors. And this summer I had a high school student who interned in the lab for the summer. So I usually have 8 or 9 people working for me, about half of those full-time. So the graduate students are sort of full-time. They work 40 hours a week on their research projects. The undergraduates come in part-time, maybe 10 hours a week. In case you don't know this, for graduate students, especially if you're in a PhD program, the vast majority of your time is spent doing like hands-on science work. There's very little coursework involved.
And so for the high school student, do you have to apply for the Purdue University summer program for that, or
This this program is through the American Chemical Society, ACS, and it's called SEED, SEED. We have we have an ACS SEED in Indianapolis, but it's all over the country.
Thank you for that. Can you share some recent breakthroughs or findings from your research?
So related to the work that I just talked about, detecting these designer drugs, one area that we were very keen to work on is the investigation of non-fatal overdoses. So if somebody dies, then samples of their blood are sent to toxicology labs by Indiana law. The law varies from state to state in the US, but under Indiana law, if someone dies, there has to be a toxicology screen done if it's a suspected overdose. But what about non-fatal overdoses? So let's say somebody overdoses on drugs, they go to the emergency department. Well, as it turns out, there's nothing done to determine what that person overdosed on. The person might say, well, I took heroin, or it might be obvious to the clinicians that the person took some opiate. But the person probably didn't take heroin because fentanyl and carfentanil and this other huge long laundry list of synthetic opiates are much more common now than heroin, which was the most important opioid 20 years ago. But heroin is not disappeared, but it's very much decreased relative to the new synthetic versions. And so, these folks, they get sick and they overdose, but there's really no knowledge about what they actually overdosed on. So we developed a method to test for these and identify these drugs in a way that's fast and simple enough to do in an emergency room. Most toxicology tests are extremely complex. They need to be done by specialists in the field. And so what we are working on is to make simpler technology that could be implemented much in a variety of different environments, such as in an emergency department, or maybe at a customs, border patrol entry station, to check for drugs much more rapidly and identify them faster and more easily.
Very nice. And okay, we already went over this question, so I think we could just skip over that for now. And how do you encourage students to develop their research interests and pursue independent research projects?
So this is something that I do as part of my job, regularly, because as a professor, okay, so I teach students in a classroom, but that's really only, a fraction of what I do. A significant part of what I do is run a research lab. And there's really two goals of the research lab. One is the actual science, which I'm interested in, but the other one is training the students so that they can become capable scientists in their own right. So we have a nice sized undergraduate forensic science program at my university. We bring in about 100 students a year, roughly half of whom are going to drop out because, science degrees are hard. And, those folks, they should have, by the time they graduate, laboratory experience. And I don't mean like the teaching labs that you might associate with school, but I mean working in a real science lab, working on independent research projects. So I'm one of those people. I've never turned one of my students, so I bring in forensic chemistry students all the time, and we have a variety of other labs on campus that likewise take our forensic science students and mentor them on research projects. And the way I do that is I normally pair, when a new student starts, I pair them with an older student who's already been there for a little while so they can work with them, learn the basics, and then eventually they can start on their own project.
Thank you. And what are your future research plans, and how do you envision the field of forensic science evolving in the upcoming years?
I think in the future in forensic science, we're going to see more scientific examinations happening in the field. Currently, the standard is to ship evidence back to a lab. I think we'll see more investigations done at the crime scene. So an example of that might be, let's say you have an arson case and the investigators want to know if some type of accelerant like gasoline was used to start the fire. Well, the way they have to do that now is to just package up gobs and gobs of fire debris into paint cans and ship them off to a lab. And there might be hundreds of samples, and then the lab's got to try to sift through those to determine if any of them have gasoline in it or some other ignitable liquid. Well, I think, in the future we'll see more portable instruments. Maybe like if you've watched Star Wars, oh my gosh, if you've seen Star Trek, they got that tricorder that they pull out and, boop, 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 and then they can, conduct different tests on site. So it'd be something like that, where you have something that could very quickly check for the presence of ignitable liquid residues in an arson case, or check for the presence of explosives on someone coming into an airport, these sorts of things, and just do those tests much more quickly. And that's an area, and so that's a direction that I'm taking my own research. We have begun working and developing more portable instrumentation to enable faster analyses outside of like a fully equipped chemistry lab. And professional labs will of course always be the standard, but ultimately they are small in number, they're far away from where crimes and other things happen, and so it'd be good to have portable instruments that can give faster answers near the crime scene.
So you're seeing it more as the advancement to technology.
There's a lot of technological barriers to that happening, but the technology is improving at an exponential pace.
Well, let's see. You gave us a few advice, so I think can go for this one. And then we'll start with the live Q&A. I think I saw 2 questions here, or one. Oh, okay. So someone asked, what college courses are needed for forensic chemistry? And what are some jobs that someone could go into with a forensic chemistry degree?
Yeah, so forensic chemistry, actually, our students, even though they're forensic chemistry majors, they actually don't get to take their first forensic chemistry class until their 4th year of college. And the reason is because forensic chemistry ultimately is a specialized field within chemistry, so students have to get a good foundation in general chemistry before they can move into forensic chemistry. But the students do get to start taking forensic science classes in their 1st year. So we immediately have our forensic science majors taking classes that give an overview of forensic and investigative sciences in general. It touches on aspects of forensic chemistry and forensic biology, but it ultimately covers the entire field. But the student comes in, we have students start from high school in our program that have just the kind of normal science background that high school students have, a little bit of math, some chemistry and biology. And then about the jobs, most of our graduates go into crime labs. They go into labs in the state police with city or county crime labs. They go into federal crime labs. But we also have a substantial number of students who, for whatever reason, decide not to go into a forensic lab. So they may go, we have lots of students that go to medical school or graduate school or get jobs in industry.
Thank you for that. And we also have another question regarding your research on Latin fingerprints. They're asking, what are the advantages on using mass spectrometry instead of other analytical techniques for chemical imaging?
There's important advantages and disadvantages of using mass spectrometry for imaging. So for anyone on the seminar that doesn't know what mass spectrometry is, it's a big, complicated instrument that's used to identify chemicals. And so the advantage is, the big advantage it has as an imaging technique is that it can identify the presence of particular molecules. So one could use mass spectrometry to map the distribution of cocaine, methamphetamine, or some lipid, cholesterol, or testosterone, any kind of endogenous molecule, map that specific chemical and its distribution on the surface. Most other imaging techniques lack that sort of very fine-tuned chemical specificity. They might be able to map a particular class of molecules, say, but not like an individual molecule. Now, there are important disadvantages as well. The main disadvantage is when it comes to imaging techniques, mass spectrometry is very slow and very expensive. There are other ways of doing it much faster. So kind of have to decide where you want to be on that spectrum between, slow and complicated or fast and cheap.
Okay, thank you. And yeah, I think that's it for the webinar. So these are all of Scienceholic's social medias. So please give us a follow if you're interested. YouTube is where we're going to publish all of the recordings. You can also find it on our website. And attendees, if you're interested in working with us, there are various ways you can. There's 6 teams, and I am in the outreach team. You can also submit an article to be published. If you want a low commitment way to help us, you can also become an ambassador. And lastly, please join our mailing list for updates on new article or magazine release and webinar updates. And yeah. Oh, and here is the list. Okay, and then here are some of our partners for the webinar that's also working on the magazine with us. It's coming out soon in September. And please note that there are going to be 2 volumes of chemistry themed magazine this time. So stay tuned for that. And again, thank you so much for attending the webinar, and to Dr. Manicke. Thank you for your time again. It was really, really interesting. I had a great time, and I learned a lot. And yeah, so please stay tuned for our next session, which is going to be at 8:30 p.m. today, for driving hydrogen, hosted by the STEM Explorers. Thank you so much. It was
My pleasure.
meeting you.
Yeah, my pleasure. Thank you for the invitation. Goodbye.
Thank you, Dr.
Bye.
Manicke.